So I want to do a video on Bitcoin addresses and what exactly makes up a Bitcoin address. It's obviously a term that you hear a lot when we talk about Bitcoin transactions, and most blockchains involve some kind of address concepts, and Bitcoin is one which I'm going to go into in some depth. I apologize for my voice. I still have a cold and I'm kind of cooped up in bed, but I really want to sort of keep up the momentum on this track, so please bear with me. I know I look a bit like Dr. Death, but hopefully this will be useful. So I want to go into depth about what makes up a Bitcoin address, in terms of how it's derived, where it comes from, and again I'm going to demonstrate in some sample actual transactions exactly what the addresses are, and then hopefully all will become clear. So let's make a start. So before we drill in any deeper, we're going to go back to our blockchain.info site, and I've got a sample transaction on the screen here. And as I hope we know by now, obviously this is a graphical representation of a transaction with the inputs on the left and the outputs on the right. And the way that the outputs are represented are essentially just a list of Bitcoin addresses along with the amount that's payable within the transaction to each of the corresponding addresses. So with this particular transaction, we have two inputs being spent and we have two outputs that are the recipients of the Bitcoin being spent in this transaction. So basically in this example, I'm going to take this address here, this sample address here, and I'm going to basically show you exactly how that address is derived. Obviously, we're not going to show you the private key from which it's derived. That's kind of the whole point of Bitcoin. But I want to show you the process by which it's actually derived. So if I click on the link, I can actually see all the transactions which this address has been involved with. Right? So this transaction here has basically paid this amount, 0.2142 bitcoins, to this address here, and then spent some change back to itself, that own address. Generally speaking, reuse of addresses for multiple transactions is not something that is recommended with Bitcoin, just because it starts to limit the anonymity, because people can essentially monitor, because the blockchain is completely public. Then and as you can see here, you can start to see the number of transactions that the one particular address has been involved in, and obviously nobody knows who this particular address belongs to, but you can still see spending patterns emerging, and therefore it's recommended not to recycle Bitcoin addresses. I'll go into more detail on that topic in later videos, but that's really that's kind of the transaction, sorry, the address homepage. So on this site, every block has a homepage, every transaction has a homepage, and then every Bitcoin address has a homepage. So I want to show you how the Bitcoin address is actually derived, right? So this, you typically for a Bitcoin address, you'll see a number starting with 1 like this. Okay, now where's this number come from? Now in the previous videos we've talked about public and private keys, which are, I guess, the backbone of the Bitcoin system. The Bitcoin address, which is the public piece of information that a sender or a spender of a Bitcoin transaction uses to denote who the recipient of that Bitcoin is going to be, that is derived from the public key belonging to the recipient of the transaction. Okay, so I'm just going to go back and kind of draw a diagram to make a bit more sense of this. Okay, so I've drawn a little diagram here of the process by which we derive our Bitcoin address, which is the nice human readable address that we see in the blockchain info, which denotes the recipient of the transaction. How we derive that from from our private key that we have, right? So if we're the owner of a private key, we want to be able to advertise to people what's the corresponding public key address, or let's say Bitcoin address, so that they can do business with us, so they can send us money when we give them nice things, like coffees, etc., etc. So how do we do that? It's actually really not that complicated. Please don't be intimidated by this diagram. I'm going to go through it step by step now. So the first thing we do is, so we take the private key. Okay, we take the private key that's in our Bitcoin wallet, right? And the Bitcoin wallet will then generate, using something called elliptic curve multiplication, right? It uses that to generate a corresponding public key. And if you haven't seen my video on public keys and private keys, please go and watch it now. I'll link it there. It's essentially, it's all about the fact that the public key and the private key are intimately related to each other, because they can asymmetrically encrypt and decrypt content, right? And so you generate the public key from the private key. Then what we do is we take that public key, right, which is just a big binary number, and we put it through a SHA-256 hash, right? If you haven't seen my hashing video, please watch it. I'll link it there too. And that creates a 256-bit digital footprint of this particular. I'm just going to make a bit more room. Footprint of this particular public key, right? And then what we do is we put it through another hash, and it's basically abbreviated here to RIPEMD160, and this stands for, a bit of a mouthful, Race Integrity Primitives Evaluation Message Digest 160. Now 160 is the number of bits in the output. So by putting the output of this SHA-256 through this, we reduce our hash from 256 bits to 160 bits, right? Now the output of this, and it's all in green here, is called the public key hash. The public key hash is the actual number that we specify when we create a transaction to spend these bitcoins to a recipient's address. It's this type of transaction is called a pay to public key hash transaction. And in the next video, I'll just give you a very quick preview here. In the actual output scripts for the transactions, if I show you down here, here's an example of an output script. When we create a transaction, the output script we specify is not the actual human readable Bitcoin address. It's actually the public key hash. The two are very closely related, and I'm going to show you exactly how here, right? Just remember that public key hash you see here, right, is this number down here. It's not this one up here, even though the two of them are closely related, right? So I just want to reiterate that. So once we have our public key hash, right, which is 160 bits or 20 bytes or 40 hexadecimal characters, what we then do is we add what's called a checksum to this, right? So the first thing we do is we add a 1 byte prefix, which basically denotes the type of the type of address that we're creating. Now, for this particular type of transaction, as I mentioned, this is called a pay to public key hash transaction, which is it's probably the most common type of transaction, and the one that I'm demonstrating here, where you're saying, I'm basically paying this Bitcoin to whoever can prove that they are the owner of this particular public key hash, right? For that type of transaction, we always add a 1 byte prefix of 00, right? So 0x is our hexadecimal representation, right? So just so you can ignore this, the 00 just means that our one byte prefix is basically 8 zeros. Okay. Then what we do is we just put that prefix on the front of our public key hash, and then we take that, so everything in the red dotted line, and we put it through another SHA-256 hash, and then another SHA-256 hash, right? And then we have this 256-bit digest of the public key hash. I know it seems like a crazy amount of hashing going on, but you'll see why in a second. So we've got a 256-bit hash that is a combination of the prefix and the public key hash. Now what we're doing here is we're adding a checksum to the data. A checksum is a way to ensure that if I send this data here, right, with a checksum on the end, then anybody who receives this data can verify that by hashing this data here, okay, and then checking the checksum and verifying that they're consistent, they can verify that nothing was corrupted or changed in the actual transmission of this data. What we do is we take the first 4 bytes of this 32, so it's 256 bits, so it's 32 bytes, right, 8 bits in a byte. We take the first 4 bytes and we append them to the end of our prefix plus public key hash combination. So now we have this overall thing in gold here, right, which is basically just a long number with a, which is comprised of a prefix, a public key hash from a ripe MD160, and then our 4-byte trailer, which comes from the SHA-256 double hash of the first 2. Now, if this sounds a bit confusing, just leave comments down below, and I'll try and explain it in the text. It's just bear with me. It's not as complicated as it sounds. So, if you see here, the recipient of this message, as long as they know that basically the last 4 bits of this whole thing in gold are the checksum, right? And you tell them, right, what you have to do is you have to basically take this bit, double SHA-256 hash it, and take the first 4 bits and compare them with this. And if they're not the same, then something has gone wrong in the transmission of this data, and you can then re-request it or something. So that's why we do the checksum, and that's why we use this format for Bitcoin addresses. It's so that it's to avoid. So let's say, for example, somebody is copying and pasting this address in a transaction, because human error can creep in here. It'd be very easy, for example, to basically get one of these characters wrong. Now, what will happen then is that this check will basically be, this check that I've just described here will allow such an error to be detected automatically and will be detected straight away as an invalid address. Okay, so it's virtually impossible to send an incorrect address with typos and for it to be validated. Okay, but there's one more step before we actually get to this beautiful human readable address here, which is to take all this in gold, right? So the prefix, the hash, and then the checksum bits, and then we put it through a Base68 encoder, right? Now, Base68 encoding is an encoding scheme which basically takes a long binary number, right? Just a long stream of bits, and encodes it into human readable characters that are more recognizable, but also much shorter, right? So you can see here, I'll show you an example of the Base64 check. So in this table here, I can put this link down below. We can see that the characters that we use are basically all of the numbers from 1, I should say 1, not 0. So 1 to 9, and then all the capital letters, but omitting capital O, right? And capital I, right? So H goes straight to J. So capital O and capital I are missing from here, and so is the number 0, right? So basically, if you're familiar with Base64 encoding, which is basically an encoding scheme which includes all of the small, so the lowercase letters, all of the uppercase letters, and then 2 extra punctuation characters, typically plus and slash. Base58 is a similar concept, but it actually omits certain key characters that would be easily mistaken by humans, right? So if we go back to our Bitcoin addresses, what that means is that our Bitcoin addresses here will never include a capital O. They'll never include a capital I, right? I think there was one more that's missing as well. I think it's a, yes, it's a small l, right? So you can see small l is missing. So you'll never find a Bitcoin address with a small l, a capital I, or a capital O, or a 0. And that is because we, again, human beings sometimes copy and paste or write down or read out these addresses, and we want to make sure that we avoid any misinterpretations of things like, you know, capital O's for zeros and stuff. So this encoding scheme just basically eliminates those characters altogether and gives us a representation with these characters, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, etc., etc. All those characters, and that gives us our sort of our human readable Bitcoin address, right? So I want to show you how this actual transformation works. So I'm going to go backwards from the Bitcoin address, and I'm going to show you how to derive the public key hash from that. So if we go to our previous diagram, so the important point is that this Bitcoin address and this public key hash, they correspond to each other, right? They're not the same value, they correspond to each other. One is derived from the other, and the process is what I've just explained here, right? So this is the Bitcoin address here, and this is the public key hash. And I'm going to show you how you go from this Bitcoin address and how you basically reverse these steps. So hopefully it'll become very clear exactly what we're doing. You reverse these steps to end up with the public key hash, right? So here we go. So just try and keep a mental note of this diagram. So I'm going to take the Bitcoin address value, right? I'm just going to copy it. I'm going to open this really cool tool. I'm going to put it in there. This will check if the Bitcoin address is valid, right? And it tells you, yes, the Bitcoin address is valid. If I remember about the checksum, right? So if I so much as change one value here, right, to something else, right? Because the Bitcoin address contains the checksum on the end, right? This will say it's invalid, right? Because it's a bad SHA-256 checksum. And that's a really good illustration of what I'm talking about. That if anybody reads these characters over the phone and misreads one of these, then any Bitcoin software is going to be doing exactly the same validation as this, and will basically tell you, sorry, this is an invalid Bitcoin address. So there's no chance of it paying somebody else by mistake. The software will just say, no, there's been a mistake here. Please try again. Okay. So let's put the original good address back in, right? So great. This is a standard standard public address, right? So prefix 1. Remember we mentioned that. So the when we transformation into Base58 encoding, the 0 prefix always ends up as a 1 as the first character in the Bitcoin address, right? So when we see, that's why all of these public Bitcoin addresses always start with 1s here. Okay, so basically, now we have a couple of other boxes here. We have a decoder, which gives us, it gives us the hexadecimal number, right, corresponding to this Base58 encoded Bitcoin address. And that, if we just copy this, right, and I've just made a note there, that's the same value, right? So this is the hex value, right? Now, if we then, so what did we say? We said, first of all, remember the last 4, this is the hexadecimal value of our address, right? Remember, so we added a 4-byte checksum to the public key hash. So if we remove, the last 4 bytes from the end of this of this string here, right, then we get this, right, which is basically just all the way up to 8, right? So we remove 9 1, D 0, 8 3, 4 5, right? So those are our 4 bytes, which is 8 hexadecimal characters. We just chop them off the end, right, and that gives us this. So we've removed our checksum. We've basically taken the trailer and we've just chopped it off, right? So now we're left with basically just this bit, right? And then, so remember, we're trying to reverse engineer the public key hash from the Bitcoin address. So we've basically we've base58 decoded it. So we've gone in the other direction, right, to get the hexadecimal value. We've chopped off the trailer. Now all we have to do is remove this prefix, right? So remove the the one, basically the 00 from the front, right? Because 00 is our prefix. 00 in hex was 1 byte of zeros, right? And that gives us, if we just chop that off, right, that gives us this, right? And then let's just see whether this is indeed our public key hash that is in that corresponding Bitcoin transaction. So we're comparing this value and this value, and we see, okay, B657B1D00, B657BD0221. Yeah, so the front is correct, and you can see DC EE8 on the end. So these two numbers are the same. So what we've shown is basically the process in reverse. But I've shown you step by step how to go from the public key hash, which is this, right, to the actual Bitcoin address, which includes the checksum, which enables error detection when people read and copy and paste, etc., their Bitcoin addresses to each other, right? So that's really the concept of the address and the public key hash. So in the next video, I'm actually going to now that we've introduced the concept of Bitcoin addresses and public key hashes, and hopefully that's kind of deeply entrenched. And if it's not, please leave questions down below, and I will get back to you so that when I do the next one, you understand it. Now we understand the difference between public key hash and Bitcoin addresses, and we've talked a little bit about Bitcoin transactions having inputs and outputs. In the next video, we're going to start talking about what these output scripts actually mean, and really drilling down deep into the anatomy of the Bitcoin transaction to understand exactly how this sort of miracle comes to light, that we can transfer this value digitally by just having private keys and public keys and all that kind of stuff. It's, as I keep saying, it's very, very elegant. It's actually very, very simple once you get the hang of it. So please bear with me. Leave any questions down below. I'm more than happy to answer it. I do want to spread the knowledge around about this. And thank you very much for watching, and I'll see you in the next one. Bye.